force of gravity? We can figure it out, right? Anybody got a calculator out? What is it?
5.0031.
Oh, that's right. I remember that. Okay, so we got that for our force of gravity acting on the ruler. Okay? Actually, we should probably go. Yeah, that's fine. F of G ruler. Okay. What else? What other forces we got here? Okay, so we got a normal force here, right? The normal force coming from our little triangle support thing. And which way is that normal force going to point? That's going to point straight up. Okay. Do we know what that is yet? Yeah, we're going to assume it's balanced, but really we don't know exactly what it is just yet. So let's just leave that one for now. Okay? Then, what else we got?
Force on the left side.
Okay, so we got force on the left side, right? Which is going to be what kind of a force? Where's it coming from? The mass, but what's happening to the mass? It's hanging, it's being acted on by gravity. So F of G1, right? Alright. And then we have another force, right? What other force do we have? Right? We know how much, or we should be able to know how much gravity is acting on this second mass, right? We just don't know where that force of gravity is acting, right? So let's figure out what that force is real quick. It's like 0.73 or something like that. 0.736. All right, good there. Questions about where any of that came from? Okay. This object, go ahead, Sarah.
Okay, I want to know about the center of motion.
Okay.
If you move the fulcrum, will it move with it?
That will move where the balance point is, but it won't change where those forces are. Wait, not true. It won't change where one of those forces is. It'll change where the other force is. Actually, wait till next week on that same because we'll get into that a little bit more next week.
Okay.
So, in order for something to be in rotational equilibrium, what did we say the condition was? What's our definition of rotational equilibrium? Net torque equals 0, right? How many torques do we have on this meter stick?
Well, 3, but one of them doesn't count.
Actually, we have 2. Well, actually, we have 4, right? But 2 of them don't count. Which 2 don't count?
The normal force.
The normal force and so which 2 colors?
Green and purple.
Green and purple don't count. Why don't green and purple count?
No one likes green and purple.
No one likes green and purple. Because they act through the center of rotation. So it doesn't matter that we don't know what this normal force is, because it really doesn't, it doesn't matter anyway. Okay? So that means we have torque 1 plus torque 2 has to equal 0. Just like we talked about before, what do we see about those 2 torques? What kind of rotation are they going to be causing? Opposite rotation, right? So magnetically we have to call one of them what? Negative. Which one do you want to call negative, red or blue? Okay. So that means that here, negative F1 D1 sine of theta plus F2 D2 sine of theta has to be equal to 0.
What did you want negative?
We talked about, Gergis, that the red one is going to cause a rotation like in this direction. Does that make sense? It's counterclockwise where you're sitting. This one's going to cause a rotation in that direction. That's how we get the net torque. The frame of reference on the torque is equal to.
We have a graph.
I see.
What does it say?
Wow.
Are you gonna read it?
I see it.
Oh.
I see. Did he write this fast or did you?
He wrote his
told me what to write.
I really wish you would have wrote the whole thing, because then I could have made fun of him having hair and like a girl.
I want to see what it says.
How about if you just tell me that, and it's on recording, so just say that he wrote the whole pass.
Okay, Mr. Hammond wrote the whole pass. It says, we were discussing how much better football is than soccer,
Oh,
because 2 + 2 equals football.
that's good in his girly handwriting. Okay, glad we got that out.
Yeah, so
Oh, wait, you're recording this? Awesome!
Yeah, we're
Like, I
playing.
didn't miss anything!
Yes. All right. So, hey,
What are we doing?
hey, social deviance. All right. Some of us that are here to learn.
We just went from silence.
I know.
Hey.
Wait, was it quiet before we came in?
Yes.
Yes. We're
It was
working.
Wow.
What did you learn
It was
it?
like 5
Alright,
out of 100,
shush.
and now it's like 8.
I'd say so. All right. So first things first, right?
Between 68 and 70.
Theta in this formula, we said is the angle between the lever arm and the force. The lever arm in this case is just the ruler. So what's going to be our angle here? It's going to be 90, right? What's the sine of 90?
1.
Sine of 90 is 1. So do we really need the sine and theta in here?
Yes.
Well, you do, but what does it turn to be?
1.
So start plugging in things we know, right? You know F1, right? We just calculated it here. You know F2, you just calculated it here. You know D1, plug it in here. You don't know D2, that's what you're looking for, and all that has to equal 0. So go ahead and calculate what D2 is.
Elias, meter stick might be the easiest thing to balance because the middle's marked.
I know.
Yeah, literally just put it in.
Sure, we'll check that out.
Look at this kid, he's a whiz at torques.
Boom. Torque wizard.
Best nickname?
Well, I have 7 juniors in this class, so.
I'll do it.
So 1, 2, 3, 4, 5,
Even
6.
still.
All 7 juniors showed up.
I can't imagine I'm gonna
1,
have
2,
more
3, 4,
4,
5, 6.
I think a lot of
7
they weren't really
seniors
good.
actually showed up.
I think
These 2 social deviants just showed up like a minute